Okay, so in the previous video, what we kind of found was that we wanted to find the probability of a particular event occurring given a value. Now what I'm going to give you is the probability. Now you have to find the value. Now that value is actually what we call a percentile, right? So the percentile is basically separates the lower p% from the top 100 minus p%. So basically, I give you the percent or the probability, which in this case is 0.34, right? So 0.34 actually represents the area. So I know what the area is. The area is about 34% of this entire graph. This x is what we want to find. This x is what we call my percentile. This is my percentile because it separates the bottom 34% from the top 100 minus 34, right? So this is what we call the 34th percentile, okay? So does that kind of make sense, hopefully, right? Okay, so the way that we usually find the percents or the values, right, is using the inverse normal, right? So if you go to your calculator, make sure that you still use exactly the same functions, right? Or you should have gotten the sheet, right? And just look for the function inverse normal. What we require is that the area itself, right, is very, very strict. The area has to be to the left, okay? We need to also incorporate the mean and the standard deviation. Okay, so let me go ahead and do an example. Okay, so now what we've been doing is that we can go ahead and do problems that look like this, right? I give you a number like 3. If I know, for example, x is normally distributed with a mean of, I don't know, let me make something up, 7 and a standard deviation of 5. Okay, I can go ahead and do this, right? All I got to do is just normal CDF, right? From the lower bound, which is negative infinity, all the way to 3. I know the mean, the standard deviation. Cool, right? Now, I do not want that. I do not want to do that because I already know how to do that. Instead, I want to do the opposite. I want to do, okay, I know that the mean is 7 and the standard deviation is 5. What I want to know is tell me what the value associated with a probability of, I don't know, let's say this is 0.17. Okay, what x value is associated with this area being 17% or 0.17? Okay, well, this is the opposite, right? Before we knew what the x value was, I didn't know the probability. Now I know the opposite. So what would you do in this case? This is a problem where we have to use inverse normal, right? So here what we're going to use is we're going to use inverse norm. Okay, area to the left. Well, do we know the area to the left? Yes, it's 0.17. Okay, it's 0.17. Do we know the mean? The mean is still 7, and the standard deviation is 5. Okay, so we're going to go ahead and use our calculator. Okay, we're going to go ahead and do second vars, right? Still the same thing, but looking for inverse normal. Area is in this case 0.17, right? The mean in this case is going to be 7, and the standard deviation is going to be 5. Okay, what we're going to find is that this answer is going to be 2.23 approximately. Now notice, this number is not a number. It's not a probability. This is a number, right? Sorry, I said it wrong. Okay, so this number is not supposed to be a probability, right? So this number is 2.23. So that means if I do normal CDF, right, from negative infinity to 2.23, what I'm going to get is 0.17. So you can go ahead and look at it if you want. You can go ahead and use normal CDF. Okay, from my lower bound, negative 1 million, right, all the way to 2.23 with the same mean 7 and the same standard deviation 5, and what you're going to get is some number close to 17. So this is basically all it is. Okay, let's do another problem. So let's change up the mean. So let's say now I want my mean to be 100 and my standard deviation to be 15. So let's say these were IQ scores, right? So what I want you to find, the top 10% Okay, and I also want you to find the 25th percentile. Okay, so let's say if we can find that out, 25th percentile. Okay, so let's go ahead and graph it. So that's always where you want to go ahead and start off as. Okay, so I'm going to go ahead and start with the graph, right? We know that this is normally distributed. The mean in this case is going to be 100, right? Standard deviation is 15. Okay, so what are we looking for in this case? Right now, we're looking for the top 10%. So that means the very top should be 10% of the entire graph, right? So 10%, so let's say 10% is about right here, right? Because it's the top one, right? So this entire area is 0.1, right? It's not 10, it's 0.1, because that's just putting it as a decimal. So what we're looking for is what is the number X that's associated with the top 10%. Okay, so notice just like this one, we have an inverse normal problem, right? So this is going to be inverse norm. Okay, now do we know the area to the left, right? Because remember, inverse norm says that we need area to the left. No, we have the area to the other direction, the right? So we need to figure out what this area is. What is this area? Because I do not want the blue area. I want the area to the left. Okay, if this is 0.1, right, what should this be? Well, this one should be 0.9, right? And how did we get that? Well, we just subtracted from 1, right? So we subtract 1 minus 0.1 and we got 0.9. So this thing is equal to 0.9. Okay. All right. What is the mean? The mean in this case is equal to 7, and the standard deviation is equal to 5. Okay, so let's go ahead and put that into our calculator, right? So I'm going to have second vars, okay, going to go down to inverse normal, right? This is going to be 0.9, right? The bottom one is going to be 7. This is going to be 5, right? So what am I going to get? This is going to be, oops, sorry, I messed up. I really messed up, right? Okay, let me go back. This is not it. What we have instead is that the mean is 100. That's where we got something wrong, right? The mean in this case is 100. Oh my goodness. 100, and the standard deviation is 15. Okay, inverse normal, right? So 0.9, 100, and this is 15. Okay, and this is going to give me 119. Okay, so that looks much more better, right? Because before we got something really, really weird, right? Before we got a 13, right? There's no way 13 can be greater than 100, right? 119 makes a lot more sense, right? So 119 is the number that separates the top 10%, okay? Now what about this one, this last problem, okay? So this says, well, now tell me the 25th percentile. Okay, well, the mean is still the same. It's still 100. Okay, now remember, 25% is going to be right below it because right here is 50%, right? So right below it should be 25%. So we're looking for, this is what number X, which is a 25th percentile, corresponds with the bottom being 0.25, 0.25. So this thing, all we got to do is whenever we got a percentile problem, this is going to be 0.25, right? So what value of X corresponds with 25% of the area being below it? Okay, another inverse norm problem, right? So this is inverse normal, right? Inverse norm. Do we know the area to the left? Yes, we do. It's just 0.25. Okay, the mean is 100. I'm going to make sure that I do that right. And my standard deviation is 15. Okay, I'm going to go ahead and put that into my calculator. I'm going to put second vars, inverse norm, 0.25 is my area to the left, 115, and I'm going to get what? Approximately 90, so 89.9. 89.9. 89.9 is the number that is associated with the 25th percentile, right? And notice that 89.9 is less than 100, so it is in the right category. Okay, so that's how you do inverse normal. Hopefully at this point you should be able to do most of your homework at this point.